Okay, so we're on this last page and we are doing some crazy stuff. We are combining together more than one transformation at the same time. So here the A value is equal to -3. So we're going to see two things happen as a result of this -3. The first thing that's going to happen is that our amplitude is going to be equal to 3. So instead of a maximum and minimum of 1, we're going to have a maximum and minimum of 3. And the second one is that negative means that we're going to have a reflection. And remember that this multiplies the values on the y-axis by -1, so it reflects over the x-axis. So pretend that the x-axis is the mirror and it's going to flip. Okay, and the second thing that's going to happen is because of our b value is 2. So my period, like I said over here, my period is 2 pi over b. So it's 2 pi over 2, so it's going to be just pi. So thinking about the way cos regularly works, cos usually starts from the top, right, and then comes down like this. So we're going to have a reflection. So instead of coming from the top, we're going to be coming from the bottom, right, like this. And this value will be -3. Or eventually we're going to hit 3 on the top, and now this whole period is going to be equal to pi, so I'll write a little pi over there. So by the time we get over to pi, it'll be at the same place. Okay, now I'm going to divide this entire stretch, this entire interval, into 4 equal parts. So we have 1, 2, 3, 4, 5 key points, where the first one's the origin, and each of those is a quarter of my period. So that's pretty easy to do. Pi into 4 equal parts is pi over 4. So this one will be pi over 4. This one will be pi over 2. This one will be 3 pi over 4. You know what? Let's switch to green so it shows up a little bit better. And now we say, okay, let's just do our dots. This one goes to the origin, goes to now our maximum, back to the x-axis, and then to our minimum. So now let's draw a nice smooth curve. And here is our result. And in fact, we can even, if we try to make these intervals about right, we could even do the same thing. We could go draw a whole period in the negative. There we go. And I keep having to remind myself, so I'm sure I have to remind you guys as well. Put those little arrows at the end to show that that function is continuous, that it does continue. All right, so that's how you do the -3 cos times 2x. So we put together two different types of transformations, an a and a b. Now that's method 1, using transformations. Here is another method, is using our key points. So I'm just going to remind myself that a is equal to -3, and b was equal to, what was it here? B was equal to 2. B was equal to 2. So you remember we did this in our transformations. We don't have any C or D yet, but spoiler alert, it does come in the next section. So if you look at the next page, you'll see it right away. So right now we're just using our A and our B transformations. So if this was our original, and just a reminder, what does the original look like? The original looks kind of like this, right? Because it starts from 1, goes like that, and then we're going to be creating an image. Yes, it does continue like that. We're going to create an image over here. So each of the x values gets divided by b. So here we're actually going to say whatever your x is going to get divided by 2, and your y values are going to get multiplied by -3. So we'll just replace this with the value for b is 2 and the value for a is -3. So I'll take my x here, and over here I'm going to put x divided by 2. So I take my 0, divide by 2, I still get 0. I'll take my y value and multiply times -3. Okay, so now I take my pi over 2 and I have to divide by 2. So pi over 2 divided by 2 is going to give me pi over 4. Okay, so just as a reminder, pi over 2 divided by 2, You can think of it going like this, or you could write it as pi over 2 divided by 2. In either case, the key, I think, for thinking about this is that dividing is the same thing as multiplying by the reciprocal. So it's the same thing as saying pi over 2 times 1 over 2. So this is a times here. So we get pi over 4 as your answer. Now my y value is 0. 0 multiplied by negative 3 is still 0. So if I quickly finish these, I get pi over 2, comma 3. I get 3 pi over 4, comma 0, and I get pi at negative 3. So I'm kind of losing track a little bit, but this one corresponds with this one over here, right? So now we can write this out again, and we can say, okay, my largest value I have, and this covers one period, and these are my 1, 2, 3, 4, 5 key points, right? 1, 2, 3, 4, 5 key spots, and now these are the image of those 5 key spots, and it should give me one period. So my largest value here is pi, so I'm going to go with pi over here, and I've got my, just like I did before, and we're going to see our results are the same, aren't they, as what we just did. Okay, so that's what it looks like. And just like we did further up, we could extend it both ways. Now you might say, Mr. Speiser, really, you're not compressing it, you're just changing the scale. So yeah, you're right. So maybe on the right here, I'll draw the exact same answer here. So we'll do a 0 here, but I'll say, what if we go up to 2 pi here? So 2 pi means that this is pi here, and this is pi over 2. Now I have to draw pi over 4, so I'm going to have to go pi over 4, pi over 2, 3 pi over 4. So my dots here, and if this was 1, then maybe we'll put 3 up there, put minus 3 down there. So now we can see this effect that we actually are compressing it when I don't change the scale like I did before. So we get this same. Okay, so we get that same sense, and this is the same function. Oh, I'm not doing that well at it. This is the same function as this one, just the way I did my scale. So I just wanted to show how, if I go up to a value, yeah. So here is an example where it goes up to 2 pi. So there's an original one of y equals 3 cos x, and now here is one where when I changed the b value, you can see how it compressed. So this is acceptable as an answer. This is also acceptable as an answer. This one shows that compression quite well. All right, so what I would like you to do is do these examples here, or refer to these examples. So if you want to see more examples that are made in the textbook, that's where the examples are done. This is the homework here. And 1 to 11 looks like a lot, but it's really not that crazy. So I'll see you guys next in class. Thank you.